Hi, my name is Josh Udy. I'm the Elementary Mathematics Manager for Houston Independent School District. In this video, I'll be showing how to solve and represent multiplication of a fraction and whole number, referring to the same whole, using concrete objects. I will be using counters, pattern blocks, and Cuisenaire rods. In this video, I will be representing the product of a non-unit fraction multiplier and a whole number using counters. The problem reads, there are 15 cars in Michael's toy car collection. 2/3 of the cars are red. How many red cars does Michael have? In order to represent this problem, I'm going to use counters. I use 15 counters because there are 15 cars in Michael's toy car collection. It says that 2/3 of his cars are red. This means that I first have to determine what a third is. I'm trying to find 2/3 of 15. First, I need to figure out what 1/3 of 15 is. The 3 in the denominator indicates that I need to divide the set of 15 cars into 3 equal groups. I know that 15 divided by 3 is 5. This means that 5 cars is 1/3 of Michael's set of cars. Since I know that 2/3 of the cars are red, I can show 1/3 being red and then count another third, which means that 2/3 of the 15 cars in Michael's set are red. I need to know what 2/3 is, and 2/3, 5, 10, is 10 red cars. In this video, I will be showing an equal group model of multiplication where the first factor is a whole number and the second factor is a non-unit fraction. First, I'll read the problem. Wayne filled 5 glasses with 2/3 liter of soda in each glass. How much soda did Wayne use? I'm going to represent this problem using the hexagon pattern block as the glasses that Wayne is filling. It says that he puts 2/3 liter in each of these glasses. I chose the yellow hexagon on purpose, and the reason why is because I have another piece that can represent 1/3 of it. This is important when students are choosing which block to represent. I know that there's 5 groups, so I show 5 yellow hexagons. I know that the blue rhombus represents 1/3 of one hexagon. It says in the problem that Wayne fills 5 glasses with 2/3 liter of soda in each glass. This means that I need to show 2/3 on each of these glasses. This represents the equal group model of multiplication because I have 5 groups of 2/3 in each group. This shows that I have 5 groups with 2/3 liter of soda in each group. The question asks, how much soda did Wayne use in all? When I'm looking at this model, I think I can start to combine some of these 2/3 amounts together. Like, for example, if I take the 2/3 here and put it here, I know that this represents that he used at least 2 liters of soda. And then I can move this one here. This means that in all, he used 3 1/3 liter of soda to fill all 5 glasses, which is actually the same as 10/3 liter of soda. I can see this here, 3/3 and 3/3 and 3/3 and 1/3 is 10/3, which is the same answer. In this video, I will be showing an equal group multiplication problem where the first factor is a whole number and the second factor is a non-unit fraction. I will be using Cuisenaire rods to model this, but before I do, let me explain something that you'll want to do with your students when using Cuisenaire rods. Before you begin work with students using Cuisenaire rods, you'll want to have them line them up. I typically ask students to put them in ascending or descending order. The point of this is simply so that students can begin to learn the length of each rod. Using the one white as a unit of one length, students quickly learn the color name of the rod in connection to its length. This is an important first step that you're going to need to allow students to explore before beginning. Let me begin now by reading the problem. Gina used 3 tubes of blue paint to paint the lake in her picture. Each tube holds 2/5 of an ounce of paint. How many ounces of yellow paint did Gina use in her picture? In order to first start representing this problem, the students need to determine which rod can represent the whole. And when I say represent the whole, we need to make sure the students understand which whole we're talking about. The question specifically says, how many ounces of blue paint did she need to use for her picture? That means that one whole is 1 whole ounce. Since each tube of paint was 2/5 of an ounce, this means that I need to figure out which rod can represent 1 whole ounce, which means a piece that can be broken into 5 equal pieces. Once I figure out the piece that can be broken into 5 equal pieces, then I can figure out which other piece represents 2/5 of it. Allow students time to explore. They need to be testing which rod can be represented using 5 smaller rods. Over and over again, students will pull a rod, check to see, can this be partitioned into 5 equal pieces? They'll quickly figure out which ones can do this. I'll start by saying that the orange represents 1 whole ounce. I need to use the orange because it's a length of 10, and I know that 10 divides by 5. That means that each red rod represents 1/5 of the whole. Let's think about this very carefully. The orange represents 1 whole ounce. Each tube of paint was filled with 2/5 of an ounce. I know that this red is 1/5 and this red is 2/5. These 2 red pieces together represent 2/5 of an ounce. So these 2 red pieces together represent a tube of paint. Since I know that she used 3 tubes of paint, I can represent this with the rods. Let me show that. These 2 reds here represent 2/5 of an ounce. These 2 reds here represent 2/5 of an ounce. And these 2 red rods here represent 2/5 of an ounce. I could actually line up the purple here to say each purple represents a tube of paint. So look at this carefully. If each purple represents a tube of paint, then it's composed of a red and a red, 2/5 of an ounce. The orange represents 1 whole ounce. The red represents 1/5 of an ounce. I have 2 of them because each tube of paint is composed of 2/5 of an ounce. This means that I can now represent what Gina used. Since I know that Gina used 3 tubes of paint and that each tube held 2/5 of an ounce, I can put the 3 groups of reds together to figure out how much of a full ounce or how many ounces of paint Gina used. Notice that I moved these all in comparison to the orange. The orange represents 1 whole ounce. This represents 1 tube of paint. Here I have another tube of paint, and here I have another tube of paint. What does this mean? It means that Gina used 6/5 ounces to paint her picture. It's kind of running past my 1 whole, so students might choose to represent another ounce by putting another orange rod down. Here I see that she used 1 full ounce with this orange here, and then she used part of another ounce. How much of the next ounce? 1/5 of it. So here we see that 6/5 ounces is equal to 1 1/5 ounce. Now that I've represented the solution to this problem, let me explain a common misconception that students sometimes have when representing fractions using Cuisenaire rods. Say that your student chooses the orange to represent 1 whole ounce. When they're asked to show 1/5 of the ounce, Students may grab the yellow rod because it's 5 long. Students often think that because it's 5 long, it represents a fifth, when in actuality, the yellow is not a fifth, but a half. So here, the yellow would represent a half of an ounce, not a fifth of an ounce. So you'll want to watch for that type of thinking.